Okay, as a secondary question here, this is going to be a little bit trickier. Now we're going to have our projectile question, and we're going to combine that projectile question with a moving target. You want to shoot a tank that is currently 500 meters away. So here's the little tank. You have an artillery gun angled at 40 degrees above the horizontal, so that's a 40. Let's try that again. And you want to know what initial velocity you should fire it at so that the projectile will come up and come back down and hit our little tank. The tank is moving towards you at 35 meters per second. So this is going to be a little bit of a tricky one because I don't know my initial velocity. I'm going to call my initial velocity v. And that just gives it a nice simple variable name so that I can divide it into components. That means then that the vertical part of that, v sine 40, is equal to, I just got to hit sine 40 here, 0.643 v, and v cos 40, 0.766 v. Now, we can, again, do our vertical and our horizontal. In the vertical direction, we have an acceleration of negative 9.8 meters per second squared for our actual shell, an acceleration of 0 in the horizontal direction. Time is going to tie these guys together, so I have to include time. Vertically, I want this object to come up and come back basically down to the same height. So I'm going to assume that my delta D here is 0. And in the vertical, my displacement, this is going to be a little tricky, so I'm going to hold on that one for a second. My initial velocity in the vertical direction is going to be 0.643 v, and my initial velocity in my horizontal direction is going to be 0.766 v. So I've got this variable kicking around, but beyond that, I kind of have enough information in both directions that I want to try and write an equation. There's just this dot, dot, dot that I've left off. The distance here was supposed to be 500 meters. But this tank is coming towards you at 35 meters per second. What that means is that the horizontal distance that the shell should travel needs to be 500 meters minus the displacement of the tank during the question. Now that we're assuming the tank isn't accelerating, so we can use the simplified equation that the displacement of the tank is equal to the velocity of the tank times time. So it's going to be 500 meters less 35 meters per second times whatever time we come up with. We can't say exactly how far the tank gets towards us because we don't know how long the projectile is in the air. So we have to leave it in as a variable. Okay, a little pause there, but we're back to it. Okay, let's try this one more time. So like I said, the tank is coming towards you. It was a total distance of 500. We don't know how long it has to come towards you, so we have to leave that t in as a variable. Now let's look at these other two equations. In the vertical direction, delta D equals v1t plus 1/2 at squared. That's actually the equation I'm going to use all the way through this. We know that we want the shell to return to its original height. We don't know v1, but we have it in terms of a common variable, so we'll make that substitution. T minus 1/2 9.8 meters per second squared. I'm not going to carry units around through this whole question, but I'll put them in at this point. So this is in the vertical direction. In the horizontal direction, delta D is equal to v1t plus 1/2 at squared. Delta D, we don't know what it is, but we know we have it in terms of how far that tank gets to move over. 500 meters minus 35. T is equal to 0.766 v, which is useful again because it's a common variable, plus, and this is nice, that whole acceleration term is 0 because the acceleration itself is 0. I'm going to solve this equation for t and substitute it into the other side, although you could solve either equation. So I'll move the 35 over to this side. 35t equals 500 divided by 0.766v. And that gets me an equation for t. But let's keep in mind here that I want to simplify this as much as possible before I make that substitution. So 0.643v minus 4.9t, and I can factor a t out of both of those. Now since t cannot equal 0, that's not a useful solution, I can ignore this root of t. Or if you want to think of it, I can divide both sides by t or something like that. Anyways, with that in mind, now I can... what did I do here?